So our objective today is to understand and use a postulate proving triangles are similar. Two triangles are similar. Come on, my friend. You're going to come and play with us today? Okay, so we got it now. We're good. We are good. All right, let me know. Everybody good? Anybody need more time? Okay. Okay, everybody good? All right, so let's move on forward here. And here is, oh, this is going to be a fun one to draw. Let's start with the diagram. Yeah, I know, exactly. Okay, so we've got this weird looking funky shape, HKOFG. I am going to tell you that I've got a right angle in two locations. I am going to label two angles as 1 and 2. So in my given, I have that angle H and angle F are right angles. Oops. And I want to prove that HK times GO equals FG times KO. All right. So let's kind of look at what those guys are. HK times GO, FG times KO. So the first two sides, we've got a short leg times a hypotenuse is equal to a long leg times a hypotenuse. So what do you think you would need to have prior to that proof statement in order to get that particular statement of HK times GO equals FG times KO? Okay. Well, right before that, what do we need to have? Guess we're going to need to have a proportion. Okay. So let's see if we can figure out how to write a proportion. So let's do HK, so long leg is to long leg as hypotenuse is to hypotenuse. So we've got the blues are in a ratio to the greens. Okay? Now, those sides would be considered corresponding sides. So what would I need? Kai, I'm going to talk to you. What would I need in order to say that I have those two sets of corresponding sides would have the same ratio.
Similar triangles.
So if I can prove those triangles are similar, then I'd be able to use this, because the definition of similar triangles, one of them is that you have corresponding sides of similar triangles are in proportion. So it's kind of like CP/CDC, but not. So that's what we're going to have to do, is prove those two triangles congruent. Similar. So we just learned a postulate that says if you can prove two angles of one triangle are congruent to two angles of another triangle, then you have similar triangles. How am I going to prove the two angles are congruent?
Vertical angles are congruent.
Angle 1 and angle 2 are vertical angles. What's the other one?
H and F.
Okay, I've got right angles. Now here's the deal. Me saying that they're right angles does not prove that they are congruent. I have to go through that litany of steps that gets me to the two angles are congruent. Don't look so bored about it, for crying out loud. All right, I think we got a game plan here. First, we're going to start by proving the two triangles are similar. So we start with our given angle H and angle F are right angles. Oops. So that's our given. So now we're going to go through proving those two angles are congruent. So the measure of angle H equals 90, and the measure of angle F equals 90. And what's the reason for that? Definition of right angles. So we get the measure of angle F would be equal to the measure of angle, measure of angle H would be equal to measure of angle F. And what's the reason for that? Yeah. It's either substitution or transitive property of equality. Okay? And then angle H is congruent, because remember the postulate says you have to have two sets of congruent angles. Angle H is congruent to angle F. What allows me to say that? Zap is what I heard. Say that again? Definition of congruence. Okay. Thank you, Hannah, so I could hear what you said. All right, and then you guys told me we had vertical angles, so angle 1, and notice H and 1 go together, so I have to keep them on the same side. Angle 1 is congruent to angle 2, and that is vertical angles are congruent. Not definition of vertical angles. Definition of vertical angles says two angles that have a common endpoint and whose sides are opposite rays. That doesn't say anything about them being congruent. Okay. Now I have enough to prove that the two triangles are congruent. So here comes the hard part. I got to get all my letters in the right orientation. Georgie.
For number 5, is it angle?
Oh, sorry.
Angle 2 or
It's congruent. All right, so I'm going to do it this way. Start with the right angle, go to the angle 1, and then the leftover angle. Start with the right angle, go to angle 2, and the leftover angle. Oh, sorry. I always do that. I'm so used to doing... There. So I get triangle HOK is similar to triangle FOG, and the reason would be angle, angle, similarity postulate. Okay. And then based on what we know about similar triangles, I can get that proportion that HK over FG is equal to KO over GO. So remember, we're doing corresponding parts from one triangle to the other. Notice that I'm using the small triangle on the left, big triangle on the right, small triangle on top, big triangle on the bottom, okay? And that would be corresponding sides of similar triangles are in proportion. That's how we use those proportions. Allie.
Would it matter if you have the HK and FG?
Well, here's the deal. When you do your cross products, you would probably get FG times KO on the left, and we want it to be on the right, okay? So then that gives me HK times GO equals FG times KO. And what's that called? That's your cross product property. Okay? So that's what you guys get to practice on your homework tonight.